let us discuss this theorem. So in this theorem, what we have a matrix space XD. Okay, I will draw the diagram here. So this is a matrix space XD, given matrix space XD, and we have its subspace Y. So Y dy is a subspace of this matrix space XD, as well as what have they mentioned? A is subset of Y. So there is some A which is a subset of Y. So see, in this theorem, what we have to prove, actually there are two sub-questions. Out of that, we will discuss first sub-question. In first sub-question, what we have? A is open subset of Y and Y is open subset of X. So what we have to prove? We have to prove that A is open subset of X. Getting? So let us start with the given information. So I have already written A is open in Y. So you know that if A is open in Y, we can write A is equal to G intersection Y, where G is open in X. Okay, G is open in X. So any open subset of Y can be expressed as an intersection of open subset of X with Y. This result already we have discussed in our previous videos. So that result I use here. Okay, so here what we have, G, which is open in X, as well as the given information is Y are open in X. See, G and Y, both sets are open in X. So see, if two sets are open, intersection is also open. So I will write implies G intersection Y is open in X. So the reason is finite intersection of open sets is open. So this result we use here. Getting? So G intersection Y is nothing but A. So therefore what can we say? A is open in X. So in this way we proved A is open in X. So in this way we completed the first sub question. After that we will go for second sub question. Make a screenshot of it. So in second sub question, what we have? A is closed in Y. Same diagram I will continue. Okay, A is closed in Y, Y is closed in X. Then we have to prove A is closed in X. Let us start with the given information. We have A is closed in X. So A is closed in X. So that's why we can write A is equal to F intersection Y, where, see, A is closed in Y. A is closed in Y. This is given information. So where F is closed in X. So we are already familiar with this result that if you have any closed set in Y, then definitely that set is equal to Y intersection some closed set in X. So that's why I could write this way. Okay. So what we have here, F is closed in X, as well as the given information is Y is closed in X, are closed sets in X. See, both sets are closed in X. So their intersection is also closed in X. So implies F intersection Y is closed in X. So the result is arbitrary intersection of closed sets is closed. So that's why we could write their intersection is also closed in X. But the F intersection Y is nothing but A. So therefore conclusion is A is closed in X. So in this way we proved our set A is closed in X. So we completed this theorem here. Make a screenshot of it. After that we will stop. Thank you. Bye bye.